Okay, this is the module 2 of our work on vectors. In this module, we'll be talking about representation of vectors in a rectangular coordinate system. So vectors can as well be represented in rectangular coordinate system, and we make use of the things to note in this module. We will be noting the use of I and j as unit vectors of x and y axis. You've already known what unit vector means. So the magnitude of I here means 1, the magnitude of j means 1 too. So the difference between them is their direction. I is pointed at the x direction and y, and j is pointed at the y direction. So we also have negative I, that is if we are looking for the negative x direction. We also have negative j, that is if we are looking for the downside of the y-axis. And then I want to quickly define this vector on the x-axis. This vector on the x-axis whose magnitude is this x is called xi, and the vector whose magnitude is y on the y-axis is called yj. So we have a position vector OP. You can see this OP is a position vector. How do we now describe the vector OP? We describe the vector OP by the sum of their respective x direction and y direction. What do we mean? We say, okay, just like we illustrated, we had an illustration in module 1. What we did to call this xi plus yj is that we assume that the young man moved x direction to x axis, then moved y direction to y axis. So that is what we have. So by so doing, we found the resultant effect of it. And what we did was to actually mathematically translate this vector yj to become pm. It's a translation, so that we know that the starting point of x is at 0, the terminal point is here, therefore the starting point of y will start from the terminal point of x to the final position. So such position vector is xi plus yj, and the magnitude of that vector is a Pythagoras. You can see we have a right angle triangle there. It's a Pythagoras of the right angle triangle, which is s square plus y square all square rooted, and the angle it makes with the horizontal is gotten from by the use of trig ratio. You remember your SOHCAHTOA. Tan theta is equal to opposite over adjacent. So that is what we have. And then there are several other ways of getting the values of cos theta, sin theta, which is what we have. What do I mean by sin theta, cos theta? You know by your trig ratio, cos is adjacent over hypotenuse, and adjacent is s. Hypotenuse is the resultant of this vector, that is the magnitude of the position vector OP, which we say we get by Pythagoras. And sin theta is opposite over hypotenuse, so we still have it as this. Okay. Representation of vectors in rectangular coordinate system. We have to note also the vectors in the rectangular coordinate system can be expressed in terms of I and j too. The unit vectors I and j are called unit base of vector. I've said that. So I've said that I and j are unit vectors of the x and y axis. So once we represent the vectors in terms of I and j, they can be added or subtracted by adding or subtracting their I and j components. So that is very simple. For example, the diagram we have here, we have our vector x as xi, yi, that is x value xi and yi, and then we have our vector y as x2 and our y2. So, and you see they are pointing, you see where they are pointing. Good. So if I want to find this vector that I marked with blue, you notice that what I would do is very simple. What I would do is very simple. By coordinate means, is very simple to get that. This is x1, this is x2. Therefore, its value is this change between x1 and x2, which is x2 minus x1. And this is y1, this is y2. So the change here is y2 minus y1, all in the y direction, that is j. So that is how to get such a vector. Otherwise, we use the concept we already know. We say that xy is equal to oy minus ox. So the vector xy is the vector oy minus ox. And notice one secret thing here. Here comes with xy, but when we are finding it now, we have oy comes first minus ox comes second. Please, you have to note that. So this is the value of our oy, which we have already written as x2 minus x2i plus y2j, and this is our ox, which is our x1i plus y1j. So they are subtracting each other, and when such subtraction happens, this is what we get. X2i will go and subtract y1i, y2j will go and subtract y1j. So they must all go and add up or subtract up with their respective component. Okay, so xy, we have it as defined here, the vector sy. Then the magnitude of the vector sy is the Pythagoras of what we have here, that is the square root of the square of the sum of the squares of each of the component. Likewise, the angle between them, becomes this. Okay, then we can use this example. We have given 2 points, x with the coordinate minus 2, 1, and y with the coordinate 4, minus 1. Find the magnitude and direction of x. You can see I stated my ox as minus 2i plus 1j, my oy as 4i minus 1j, as we have it here. So by using normal mathematics, we have xy equal to oy minus ox, and this is what we'll get. 4 minus minus 2 will give us 6, whereas minus j minus plus j will give us minus 2j. So, and the magnitude of such a vector is the square root of the sum of the squares of each component. That is what we have there. And the angle between them also, we say this we use tan theta, we say y2 minus y1 all over x2 minus x1. So that's why we have this, and theta is of course this. And what the angle critically showed there is that it is on the fourth quadrant. That is what we have here, it's on the fourth quadrant. Okay, so there are a lot of examples I've stated here. If the coordinate of y is 0, minus 5 and xy is I, find the coordinate of x. Okay, so we have the coordinate of oy, which is minus 5j, because normally it should be 0i plus minus 5j, which will result to minus 5j. Already we know that our xy is equal to oy minus ox, and our xy is given to us as I, and our oy is given to us as minus j. We are to find ox, so by that you do the mathematics, you get this. Therefore the coordinate of x is -1 and -5. Okay, so I have lots of beautiful examples for you to see here. This one we made use of it to find the unit vector of a given vector xy. So we have the position of the vector s at the origin, that is 0, 0, and the y as -1i plus 1j. So that is what we have here. Xy now will become oy minus ox, which is still -1 plus j. So the magnitude of xy will give you -1 that is squared plus 1 that is squared or square rooted, which is square root of 2. The unit vector of sy becomes the vector sy divided by the magnitude of xy. So that is how we get this. Okay, so there are several examples you have to look upon too. Some of them will lead you to simultaneous equation. Understanding them is a very beautiful thing. Our x vector is given as this and our y vector is given as this. Express 5j in terms of x and y. All we need to do is very simple. We don't know what 5j is, but we can by induction say let 5j be equal to mx plus ny, where m and n are scalars. You already know that. So, and the value of our vector s is this, we'll plug it in. The value of our vector y is this, we'll plug it in. So we add up. From here we can see that if 5j is everything we have here, 4n minus 2mi will be 0i. So this one will be equal to 0, whereas what we have here is equal to 5. That is by the concept of equivalence. Normally I should write 0i plus here should be I should write 0i plus 5j, so that we understand that 0 is for 4m minus 2m and 5 is for 3m minus, and so you solve simultaneously. If you solve simultaneously, you will now be able to find what your m and the n means. Okay, so we can also let's talk about parallelism in vectors. If two vectors are the same or opposite direction, then they are parallel. So in parallelism of two vectors, there are things you should be looking out for. For two non-zero vectors to be for two non-zero vectors u and v, if we say u is equal to kv, where k is a real number, then it means that u and v are parallel. They are parallel, that is, they cannot meet each other at any given point in time. For example, if we have u equal to say 2i plus 4j, for instance, and I have my v equal to say 4i plus 8j. These two vectors are parallel because there is a scalar that you bring out from here that will remain the vector u, and that scalar is 2. If I factor out 2 from this vector now, I will get this vector. So they are parallel and they are facing the same direction. But if I look at another vector w, and w is giving me minus 2i minus 4j, they are as well parallel because I can factor out -1 from here to give me back u. And because I factored out a negative number, they are parallel and they must face opposite direction. So the difference between the relationship between u and v is that they are both parallel and of the same direction, whereas the relationship between u and w is that they are both parallel but opposite direction. Okay, sorry, let me clean that. Okay. So the converse of the above fact is true. If two non-zero vectors u and v are parallel, then u and u is equal to kv, where k is a non-zero real number. So okay, so we have this. If u is a vector defined as this and v is a vector defined as that, and we have that m1, m2, n1, n2 are real numbers, that is are scalars and are non-zero, we will conclude that m1 divided by m1, m1 divided by m1 divided by m2 must give you n1 divided by n2. That is for parallelity to hold. So if the vector a is given as this and the vector b is given as this, and we are told that they are parallel but in opposite direction, we are asked to find c. For us to find c, it is very, very simple. How do we find c? We say 2c divided by 2 is equal to 8 divided by c plus 2. That's what we have. We have already stated that initially. So when you cross multiply, you have a quadratic equation which you solve, you get this. So you are to either conclude or reject if they are parallel. Of course they are parallel now, but we have to check if they are facing the same direction or opposite direction. How do we check that? Is by taking this value and plugging in, so that we see if freely what we said in the last slide really held. Okay, so these are common examples I gave to show parallelism and the 3-point and the collinear nature of a vector. So feel free to go through them and meet us in module 3. Thank you very much, and may God bless you.